if you like look at the progression of this chapter, right? We started with polygons, all the different sides, right? Like went from 3 sides all the way up. Then we honed in on just parallelograms, right? So we talked about parallelograms, 4 sides, both pairs of opposite side congruent. Then the next section we reversed and we talked about how to prove that they're parallelograms. Now we're going to learn more specific parallelograms. So we went from polygons to parallelograms, which have 4 sides, to now these are specific types of polygons, rhombuses, rectangles, and squares. So by definition, a rectangle is a parallelogram with 4 right angles. A rhombus is a parallelogram with 4 congruent sides. And a square is a parallelogram with 4 right angles and 4 congruent sides. So if you remember, we learned like all the properties in a parallelogram. There are 5 things true about a parallelogram. All 5 of those things are now true about a rectangle, about a rhombus, and a square because these are parallelograms, right? So the rectangle, 4 right angles, usually, I mean, we know what a rectangle looks like. Usually it's 2 pairs of short sides, 2 pairs of long sides, but they have to have right angles. That's a rectangle. A rhombus is usually a slanted, that's a really bad rhombus, but you get the point, with all 4 pairs of congruent sides. And then if a rhombus and a rectangle had a baby, it'd be a square because it gets all 4 congruent sides and 4 right angles. So all the properties about a rectangle carry down to a square. All the properties about a rhombus carry down to a square. All right, so these are corollaries, but really just properties. Okay, the first one says if a quadrilateral is a rhombus, if and only if it has 4 congruent sides. We just said that, right? The rectangle, a quadrilateral is a rectangle if and only if it has 4 right angles. And a quadrilateral is a square if and only if it's a rhombus and a rectangle. So because it says if and only if, think of these forwards and backwards, right? We know that if it's a rhombus, it has 4 congruent sides. But now we're saying if it's a quadrilateral with 4 congruent sides, we can say it's a rhombus. So you can use that to prove it's a rhombus. If it's a quadrilateral and it's a rectangle, then we know it has 4 right angles. If it's a quadrilateral with 4 right angles, then we know it's a rectangle. And then if it's a square, then it is a rhombus and a rectangle. And if it's a rectangle and a rhombus, then it's a square. God bless you. So because they're if and only if, you can read these statements in both directions. Then comes, this is a Venn diagram, right? A Venn diagram has properties that are separate and then properties that overlap. So the big box is parallelograms, right? And in parallelograms, opposite sides are parallel, opposite angles are congruent, opposite sides are congruent, diagonals bisect each other, and consecutive angles are supplementary. So that's true about every parallelogram, which means it's true about every rhombus, every square, and every rectangle. If we went a step further, we could say outside of this is a quadrilateral. And in a quadrilateral, we know it has 4 sides. And we know the angles sum to 360 degrees, right? So that could be even more general than that. So we just keep going narrower and narrower, and as you go more narrow, all those properties carry down. So we just said the rhombuses have 4 congruent sides, the rectangles have 4 right angles, and then both of these are true for a square. All right, now some additional properties about rhombuses and rectangles. The first one says a parallelogram is a rhombus if and only if its diagonals are perpendicular. So not only do they bisect each other because it's a parallelogram, but now we're saying they're perpendicular, which means they meet at a right angle. That's a right angle, that's a right angle, that's a right angle, and that's a right angle.
So it has to show the right angles.
Or it says it's a rhombus. So if you're trying to prove it's a rhombus, it has to have the right angle. If it's a rhombus, then you know it has a right angle. Second one says a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So we said that the opposite angles are congruent because it's a parallelogram, but now we're saying take those congruent angles, so this one matches this one, and cut them in half. So this matches this, and this matches this. And then the same here. If this matches this, then I can cut them in half So there are 4 of the same angles when you draw those diagonals in across from each other. And then the last one says a parallelogram is a rectangle if and only if its diagonals are congruent. So for a rectangle, diagonals are congruent. So now this whole side equals this whole side, and because it's a parallelogram, this would equal this, would equal this, would equal this. So rhombus, diagonals bisect pair of opposite angles. Rhombus, diagonals are perpendicular. Rectangle, diagonals are congruent. So what other shape does it make all this true for? A square. All of it. All true for a square. Make sense? There's a lot of memorization in this section. You add that to the parallelograms, and you're going to do a lot of application of memorization. Yeah.
So, like, all the pages we learned in the class section, they all apply to these two?
Yep, because they're all parallelograms. And the same, like, next section, we're doing trapezoids and kites. Those are not parallelograms, but all these are. So all of these carry on the properties of parallelogram. Those are quadrilaterals, but they're not parallelograms, so it'll be a little bit different. All right, so example 1 says quadrilateral ABCD is a rhombus. Find the measure of each angle. So what do we know about the angles in a rhombus? Where they meet is 90, right? These are all 90. What about these 2 angles? They're congruent. So if that's 62, this is 62. Good. Opposite them are also 62. Can I find this angle? How?
90 plus 62.
Good. 90 and 62. 152. Subtract from 180. This is 28. This is 28. This is 28. This is 28. So all you need in a rhombus is one angle, and you can get all the other ones. So ACD is this angle here, 62. DEC is this angle here, 90. EDC, this angle here, 28. And ABC, this angle here, 28 plus 28, or 56. Good. Questions so far? Okay, quadrilateral MNOP is a rectangle. What do we know about the angles in the rectangle? Let's start there. They're all 90, right? So 90, 90, 90, 90. Which means this one next to the 29 would be 90 minus 29, or 61. What happens to the one opposite there? This would be 61, right? Alternate interior. This would be 29. What? Did you say something, Mateo, or no? Okay, so PON is the big angle there. That's 90 degrees. PMO is here, 61 degrees. We would need a little more information. Actually, we don't, because they're isosceles triangles. If this is congruent to this, then this would also be 29, and then you could find that one, right? This is congruent to this would be 61. You could find the other angles that way, but it didn't even ask for it. All right, now it says PL. So what do we know about the diagonals in a rectangle? They're congruent and bisected, right? So if this is 12, this is 12. This would be 12. This would be 12, making MO 24. Good. Questions on those? Okay, 8 says quadrilateral MORE is a square. So the square Sides are all congruent. Diagonals are all congruent. Angles are 90. Diagonals are perpendicular. All that information we know about a square. So if it says ME is 7x minus 3 and MO is 6x, only in a rhombus and a square can consecutive sides be set equal to each other, right? So this would be 7x minus 3 equals 6x. Subtract the 7x. X equals 3. And if MT, which is this one, is 4x, TE, which is this one, is 3x plus 2.
X equals 2.
Go ahead, set them equal to each other. 4x equals 3x plus 2.
Then you plug it in, right, and then multiply by 2.
Good. So it didn't ask for x this time. It said find OE. OE would be this.
It'll be 60.
Good. So I would do 3 times 2 plus 2, 6 plus 2, which is 8. And then double it, because that's only half of it. OE is 16. All right, this is for 42 and 43. It says the diagonals of the rectangle intersect at P, given that PTS is 34. So if PTS is 34, which is here, and QS is 10, okay, and you want to find QR, so let's say I want to find this side, and then I want to find RS, let's say it's this side, right? What I know is that if this is 34, this one is also 34, because these are isosceles, yes? You with me so far? And then this is 34. So you can set up this triangle here. 10 is the hypotenuse. X is adjacent. Y is opposite. So I can say the sine of 34 is y over 10. And the cosine of 34 is x over 10. So it's good to review it. Like, it's not going to be on your test. I'm not going to give you a calculator, but it's good to review your trig. Remember, it's not going to go away. So